Okay, for topic 4, we're going to talk about horizontal and vertical lines. And something I've mentioned earlier is that in some situations, the polar form of the equation is going to be easier for us to work with. It's going to be easy to recognize, whatever the case may be. There are going to be other situations where converting it to the rectangular form is just going to be easier for us. Kind of just depends on the equation. There are going to be some where we really truly need the polar form. Others, it kind of just is up to you. Okay. Now, in the previous example, we looked at two situations where in polar form, we were missing one of the two variables. We were missing theta in the first one. We had r equals 3. And what we found out is that represents a circle centered at the pole with a radius of 3. Okay, so it didn't matter what theta was. We could let theta be literally anything. We just knew that r had to be 3. That gives us a circle. Okay, the second example, we had theta equals pi over 3. We found out that, hey, we're missing an r, but as long as we set our theta to be pi over 3, we kind of draw that angle out. We can go any distance along the terminal side or any distance in the opposite direction of the terminal side from the pole, and we would end up with basically a diagonal line. So that's what we ended up with. We had a diagonal line that had a slope. It goes through the origin or through the pole, and then it had a slope of root 3 when we put it into rectangular form. Here, these two are going to be much more recognizable and easy for us to work with when they're in their rectangular form. Okay, so what we'll do is we'll convert them to rectangular form first, and then we'll kind of talk about what all that means. Okay, so please remember that we do have some substitutions. Let's scroll up just a smidgen. So we do have some substitutions that we use to convert polar equations to rectangular. So you need to remember that r squared is equal to x squared plus y squared. We need to remember that x equals r times cosine theta, and that shouldn't be hard. Remember, even on the unit circle, we associate cosine with x, okay? We have that y equals r times sine of theta, and then we have tangent of theta equals y over x. So remember those substitution. Those are going to help us a lot, okay? So we have example 5 here, identify and graph each of the following. The first example we have is r times sine theta equals 2. So what this one is going to do is it's going to, well, we're going to convert it first to rectangular, and then you're going to see what it's going to do. Please remember, we do have a substitution for r times sine of theta. We know that r times sine of theta is just y. So let's go ahead and do the substitution, and we get y equals 2. We'll notice there's no x. So we can let x equal anything, okay? Just like in the previous video, we could let theta be anything for r equals 3. And then in the other equation, we had theta equals pi over 3. We could let r be anything. So when we had r equals 3, set theta to be whatever you want. Okay, when we had theta equals pi over 3 and we were missing an r, let r be whatever you want. Okay, same thing here. We have y equals 2. We can let x be anything we want. And the best way I can get my students to remember this is without an x, we're not going to touch the x-axis. And we have to touch the y-axis because we have a y. The only way that's going to happen for us is if we're parallel to the x-axis. The one exception, of course, is if we get y equals 0. Well, what this is going to give us is we're going to go 2 units from the pole in the positive vertical direction. And we have our horizontal line. So we're running in the direction of the x-axis, what would be our x-axis if we were in the rectangular system, but we're not going to touch it. Okay, so this is the equation r times sine theta equals 2. So no matter what theta you choose, when you take sine of that and then multiply it by r, you're always going to get out a 2 as the result. Okay, so that ends up giving us a horizontal line. Remember, we always associate sine with y. Okay. Now, for the next one, we have r times cosine theta equals -2. So we again have a substitution. We know that r times cosine theta is really just x. So let's go ahead and do the substitution, and we get x equals -2. So there's no y. So we can let y be anything. We can set y to be literally whatever we want. Okay, so no matter what we let y be, we're always going to get x is -2. Now, again, the way I got my students finally to understand this after years and years of teaching is without a y, we're not going to touch the y-axis, but with an x, we have to touch the x-axis. So we're going to go through the x-axis at -2, but we're not going to touch the y-axis. The only way for that to happen is if we're parallel to the y-axis, and that makes it, that happens when we have a vertical line. So if we go back 1, 2, and then go directly up, directly down. We're running in the direction of our y-axis, but we're not going to touch it. Of course, the one exception to this would be if we had x equals 0, which we do not. So again, if you have y equals 0 or x equals 0, that's kind of the exception to the if you touch this one, you can't touch that one thing, but it gets students to remember which is which. Okay, so here we have our vertical line, and remember, we always associate cosine with the x's. Okay, so basically, no matter what angle for theta we choose, it doesn't matter what we choose. When we take that cosine of whatever angle and then multiply it by whatever r is, we're always going to get a result of -2, which gives us this vertical line. Okay, so again, vertical and horizontal lines, in this case, it's going to be a lot easier. We're going to recognize them much quicker in their rectangular format. But get used to these patterns. Kind of start recognizing what these polar equations give us. So remember, if you have r equals just a number, that's always going to be a circle centered at the pole. If you have theta equals just some angle measure, that's always going to be some kind of diagonal line. When you have r sine theta equals a number, horizontal line, r cosine theta equals a number, vertical line. Okay, and just remember, sine goes with y, cosine goes with x. Okay. So I think that's it for this video. Yeah. So next we're going to look at circles, and we do need to remember completing the square. So if you have gotten a little rusty on completing the square, might be worth taking just a quick minute to go review it.